Hello students, let us look at this question. In which of the following energy of 2s orbital is minimum? The options are lithium, sodium, potassium and hydrogen. Well, we got to understand one thing very well is that the energy expression which we have learned, which we have gone through in our concepts of atomic structure, it says that energy is equal to minus 13.6 z square upon n square, which in fact indicates that as the atomic number increases, the energy of the electron would decrease. Now let me elaborate on this. We are talking about 2s orbital. Yes? Now, if we are talking about, say, lithium, we are talking about sodium, we are talking about potassium, and we are talking about hydrogen. Now, if we look at the atomic number order of these elements, hydrogen is the least, then comes in your lithium, then comes in your sodium, then comes in your potassium. So, for the same orbital, or rather for the electron in the same orbital, the attraction is more for larger atomic number. Okay, so attraction is more for a larger, or otherwise for a higher atomic number, you could say. Yes. Now, as the attraction increases, the energy decreases. Yes. What did I say? As attraction increases, yes, the energy decreases. Energy of what? Energy of the orbital as well as the electron present in it. Yes, energy of the orbital and the electron present in it decreases. Yes. So in that case, obviously, if this is the order for the atomic number, the reverse will be for the energy of the same orbital. In short, the energy would be in this manner. Okay. What is this? Order of energy of the same orbital. Yes. In short, potassium will be having the minimum energy since it has the higher atomic number. Yes. And the attraction is also more. That is the reason option number 3, that is potassium, will be the correct answer. I hope you understood the explanation. Thank you. Hello students, let's start the question. The ratio of the shortest wavelength of two spectral series of hydrogen spectrum is found to be about 9. The spectral series are. So this refers to the very popularly known hydrogen spectrum experiment. Yes, and there were these 5 series which were formed. Yes, and with respect to these series, this question has been asked. Hailing from physical chemistry, we need to recall the very first thing is the Rydberg equation. Yes. Now, what is the Rydberg equation and how does it serve us over here? So the Rydberg equation says that 1 by lambda is equal to RH, which is the Rydberg's constant, upon h into c, Planck's constant and your speed of light, into 1 upon n1 square minus 1 upon n2 square. Yes. Or we can directly say that 1 by lambda is actually directly proportional to this difference of 1 upon n1 square minus 1 upon n2 square. Yes. Now, as it has been said over here, we are having the shortest wavelength. Okay, we are analyzing the shortest wavelength, which actually means it would be talking about the highest energy Yes, highest energy spectral line, you would say. And since it is highest energy spectral line, obviously that implies that N2 is equal to infinity. Okay, taking for these concepts, let us solve. So the first option says that it's lemon and passion. Now for lemon, N1 is equal to 1, okay, and for passion, N1 will be equal to 3. Yes, so accordingly, let us lay it down. So lambda of lemons, yes, so it's going to be lambda of lemon. So for abbreviation, let me use L, capital L for lemon, upon lambda of passion, that is P, will be equal to 1 upon N1 square. So 1 upon passion's N1 value, that is going to be 3 square minus 1 upon infinity square. Since 1 by lambda is directly proportional, isn't it? And that is the reason we are going to put it in an inverse manner. Yeah. So 1 upon 1 square minus 1 upon infinity square. I hope you are getting this point. Yes. So this is going to be 1 upon 9. Yes. Since this is going to be 1 upon 9 minus 0 and 1 upon 1 minus 0. So that's going to be 1 upon 1. That is 1 itself, and 1 upon 9. As we go up in the numerator, it becomes the reciprocal, and hence it would be written like this. Yes, so 1 upon 9. Now what next? Next is your Balmer and bracket series. Yes, for Balmer, N1 is going to be equal to 2, and for bracket, N1 will be equal to 4. Okay, so we are going to abbreviate Balmer as B and bracket as BK. Okay, let us abbreviate it as BK, and accordingly we solve. So bracket would be in the numerator and Balmer would be in the denominator. Since it's 1 by lambda is directly proportional to this, so obviously it would be the reverse. Yes, so bracket is 1 upon N1 is, N1 is equal to 4. So 1 upon 4 square minus 1 upon infinity square divided by 1 upon 2 square minus 1 upon infinity square. Yes, so that's become 1 upon 16 into 4 upon 1, and that makes it 1 upon 4. I hope you understood this. Yes. Advancing forwards, bracket again comes up over here, wherein N1 will be equal to 4, and for fund, N1 will be equal to 5. Yes. So accordingly, let us proceed. So lambda of bracket upon lambda of fund. For fund, I would be using PF. Okay. Now, P has already been used for passion, and that is the reason we are using it this way. So bracket upon fund would be 1 upon 5 square minus 1 upon infinity square divided by 1 upon 4 square minus 1 upon infinity square. So that is going to make it 1 upon 25 into 16 upon 1. So that is going to make it 16 upon 25. Yes. And now comes the last one. Yes. So the last one is going to be passion and fund. So passion is P and fund is going to be PF. Now for passion, what is N1 value, guys? N1 value is going to be 5. Yes. Oh, sorry. For passion, right? Okay, let me just write this properly. So for passion, of course, the N1 value is going to be 3. And for fund, it is going to be 5. So 3 square minus 1 upon infinity. Oh, sorry. This is going to be again. Yeah. So 5 square because fund is in the denominator on the left hand side. Yes. And 1 upon 3 square minus 1 upon infinity square. So this would make it 1 upon 25 into 9. So this will become 9 upon 25. Yes. So as you can see over here, it's 1 upon 9, 1 upon 4, 16 by 25, 9 by 25. Yes. So which obviously means we have already got the answer. The ratio of the shortest wavelength is found to be 9. Yeah. So in that case, it is obviously going to be lemon and passion itself. Yeah. Because we have got it over here. So option number 1 is the correct one. I hope you understood the explanation. Thank you.
Hello friends, the question is the graph of an orbital between radial probability density function, that is psi square, and radial distance is shown below. The sum of the principal quantum number, azimuthal quantum number, and magnetic quantum number of this orbital is. So here let us first discover that is psi square is known as radial probability density function of electron. After that, that is principal quantum number is denoted by n. Azimuthal quantum number is denoted by L. So from this graph, one thing that we noticed is for s orbital, graph of psi square versus radial distance always starts from top. So since the graph over here starting from top, so this is the graph for s orbital. Now the important point to be noted over here is written. Now the formula for radial node is equals to n minus L minus 1. And according to the graph, this is the first point, and second point is R is equals to 0 denotes radial node. So these points denote radial node. So there is only one radial node over here. So n minus L minus 1 is equals to 1. N minus L is equals to 2. And for s orbital, since for s orbital the value of L is equals to 0. So putting the value in equation 1, we get n minus L is equals to 2. So n is equals to 2. So sum of n plus L is 2 plus 0, which is 2. So the answer is 2. So option 1 is correct. Thank you.